Hello and welcome to the A to Z channel. In this lecture, we will study how to convert number systems from any base to any base. In the previous lectures on this course, we did study how to convert numbers from bases 2, 8, and 16 to decimal, and vice versa. In this lecture, we will use the same methods to convert numbers. So let us take an example. Convert the number 214.23 from base 5 to base 12. First, we will convert the number from base 5 to decimal, base 10, and then from decimal to base 12. To convert a fractional number from base 5 to decimal, as we did earlier, we will use this law, where n is the base of the system. By applying the above law, we take the first right digit before the decimal point, this 4, and multiply it by the base 5 to the power of 0, plus the next left digit, this 1, and multiply it by the base 5 to the power of 1, plus the last digit, this 2, multiply it by the base 5 to the power of 2. And for the fractional part, we take the first digit after the decimal point, this 2, and multiply it by the base 5 to the power of minus 1, plus the next digit, this 3, multiply it by the base 5 to the power of minus 2. This equal to 4 times 1 plus 1 times 5 plus 2 times 25 plus 2 times 1 over 5 plus 3 times 1 over 25 equal to 4 plus 5 plus 50 plus 0.4 plus 0.12. This equal to 59.52. So the number 214.23 in base 5 is equal to 59.52 in decimal. Now after we got the number in decimal, we can simply convert it to base 12. For convenience, we will take the number as two parts, the integer part and the fractional part. Then we add the two converted parts together. First, we will convert the integer part of the number, which is 59. To convert integer number from decimal to base 12, divide the number by the base 12 until the result finally becomes 0. Traverse the remainder from bottom to top to get the result in base 12. Make two columns, integer and a remainder. Divide 59 by the base 12 gives 4 with a remainder 11, which is equal to b in base 12. Then divide 4 by the base 12 gives 0 with a remainder 4. Traverse the remainder column from bottom to top. So the number 59 in decimal is equal to 4b in base 12. Now we will convert the fractional part of the number, which is 0.52. To convert a fractional number from base 10 to base 12, multiply the fractional number with 12 until the fractional number finally becomes 0, while stop after required decimal places. Traverse the integers from top to bottom to get the result in base 12. Make two columns, fraction and integer. Multiply the number 0.52 by the base 12 equal to 6.24. So the integer part is 6 and the fractional part is 0.24. Then multiply the number 0.24 by the base 12 equal to 2.88. So the integer part is 2 and the fractional part is 0.88. Then multiply the number 0.88 by the base 12 equal to 10.56. So the integer part is 10, which is equal to a in base 12. And the fractional part is 0.56. Then multiply the number 0.56 by the base 12 equal to 6.72. So the integer part is 6 and the fractional part is 0.72. Multiply the number 0.72 by the base 12 equal to 8.64. So the integer part is 8 and the fractional part is 0.64. Then multiply the number 0.64 by the base 12 equal to 7.68. So the integer part is 7 and the fractional part is 0.68. Multiply the number 0.68 by the base 12 equal to 8.16. So the integer part is 8 and the fractional part is 0.16. Multiply the number 0.16 by the base 12 equal to 1.92. So the integer part is 1 and the fractional part is 0.92. Stopping at 8 decimal places, traverse the integer column from top to bottom. So the number 0.52 in decimal is equal to 0.62a68781 in base 12. Now we add the two converted parts together. The converted integer part was 4b plus the converted fractional part is 0.62a68781. And this is equal to 4b.62a68781. So the number 214.23 in base 5 is equal to 4b.62a68781 in base 12. This course is sponsored by the Logic Kit app. With the Logic Kit app, you can learn and solve number systems and Boolean algebra with step-by-step solutions. Let us use this app and convert numbers to see how this app explains the steps. In the Convert Number section of this app, we select the input base, for example 9, and the output base, for example 23, and write a number in base 9, for example 758.61. As you can see, the equivalent number in base 23 is equal to 13m.fe4cb859. Now let's see the steps. As you can see, the app first converted the number from base 9 to decimal, then converted the number from decimal to base 23. Let's see the steps for converting the number to decimal. Press the show button. As you can see, the steps are explained very well that you can follow to understand the solution. Now press the show button to see the steps of converting the number from decimal to base 23. Also, we got a very well explained step by step. The Logic Kit app giving you the ability to convert from any base to any base up to base 36. Also, by this app, you can find the complements and do arithmetic between numbers in different bases. And in the Boolean algebra section, you can do a lot of things like minimize the functions, solve the Carnot map, deal with the truth table, and many other things. I will leave the link to download the Logic Kit app from the App Store in the description. Don't forget to subscribe to the channel and follow us on social media. All links are in the description.